Looking at section 5.5, we're going to look at two different ways to prove triangles congruent. We start with our side postulate. This says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if we look here, our triangles are marked for our three sides. If we're saying it out, we have side AB that matches with side RS. Side BC matches with side ST. And side CA matches with side TR. So then our triangle ABC is congruent to triangle RST by side. And again, how the letters match up is important. Okay. So A matches with R, B with S, C with T, and I say that when I write my congruent statement. So example 1 is just looking at our pictures and deciding whether those triangles are congruent by side. So if I look here on the first one, we have 8s for JK and KM. We have 9s for ML and JL. And then LK is in both triangles, so that's reflexive. So this is yes, and my explanation would be reflexive and side. So reflexive is how I got the side I was missing. Side is how I know they're congruent. When we look at B, we have ST and VW matched. We have WT and RT matched. But the side here and the side here, we don't have matched, and we don't have any information about them. So then we can't do side, and that would be no. Okay. Example 2, we're looking at doing this as a proof. Really the difference between what we just did and the proof is how we're stating things out. So I have my given, which is two different statements. I'm trying to prove my two triangles congruent. So FJ is congruent to HJ. We always start with our given. That's marked. G is the midpoint of FH. That is not marked because I want to say something with it before I mark it. So whenever I have a key word, like midpoint, that's one of the first things I want to use. So if G is the midpoint, that means FG is congruent to HG. And the reason I know that is the definition of our term, definition of midpoint. Okay, so now I can mark that. Now I have two things marked. Whenever I'm doing a proof, I need three things marked. Okay, so I need one other thing marked, but I have JG in both of those. So I can say JG is congruent to JG. That's reflexive. My last step is always going to be what I'm trying to prove. I have my three things marked, so I can say my triangles are congruent. And then my reason for that is going to be one of my ways to prove triangles congruent, which right now we're going over side. Right, so that's, and I have my three sides marked. Okay. Eventually we will have 5 of those, and it's going to be one of those 5 things. Flipping the paper over. Example 3. Congruence in a coordinate plane. So use the given coordinates to determine if ABC is congruent to DEF. All right, so realize I have two triangles here. So first thing I want to do is graph these out. So A is 0, 0. B is 6, 5. And C is 9, 0. Oops, drawing badly here. And then D0, -1. 6, -6. And 9, -1. One of the advantages of drawing it out is that if I have a straight line, it's easy to see. So here, this is A, B, C, and this is D, E, F. So AC is congruent to DF because they're both equal to 9. Right? Then my other ones I need to check. So AB should match up with DE, and BC should match up with EF. And the way I'm going to check those is my distance formula. Right? So remember, our distance formula is x2 minus, actually we'll read this to the side here. My distance formula is x2 minus x1 squared plus y2 minus y1 squared. All right, so when I'm doing this now, A is 0, 0. So I'm just squaring my B. So I have 6 squared plus 5 squared, which is 36 plus 25, which is the square root of 61. DE, right? I have 0 and 6. I have 6 squared. -1 minus 6 is my 5 squared again. So actually, once I'm here, we were looking for something, but these two are exactly the same. I'm good. I can say, all right, I know these work. All right, if you don't see that, continue working. BC will see the same thing as C is at 9, 0. So 9 minus the 6, I have -3 squared, and then 5 squared. EF, right, we have 9 minus 6 again, so I have the -3 squared, and I have -6 and -1, so I have -5 squared. So when I square out both of these, I get 9 plus 25, right? Which will give me the square root of 34, but they're going to be equal, so I'm good there too. And then my triangles are congruent by side, side, side. Then we have our second way to prove triangles congruent on this paper, our third overall, which is hypotenuse leg. Okay, so hypotenuse leg says if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So this only works with right triangles, and I want the hypotenuse and either of the legs. So in here, like AB and AC are legs, DE and DF are legs. I need one of those pairs to match up. And realize this is the only one of our things. When we abbreviate this, we abbreviate it HL. It's the only one that doesn't have 3 letters in it, but having a hypotenuse means there needs to be a 90-degree angle. So we still have the 3 things that we need to mark. Okay. So example 4 is a fill-in-the-blank proof. Okay. Now they do split up the given here. So if you're doing one like this, watch for what they're giving you. All right, the first thing they give me is AC equal to EC. That's given. Okay, that's here. And that's given, and that's marked, AC and EC. So I have my one marking. Then 2, all right, we have AB perpendicular to BD and ED perpendicular to BD. That's given. All right, and now the lines here got messed up a bit. These two match up. So definition of perpendicular lines lets me say angle B and angle D are right angles. Right? So triangle ABC and triangle ECD are right triangles. That's the definition of right triangles. They have a 90-degree angle in them. So they have to be 90 degrees. Then AC is a bisector of BD. That's my last given. Okay, so remember, a bisector means cut in half. Right? So if I look at, let's mark this. We said these are right angles, so we'll mark them as right angles. Bisector means it cuts in half. BD is being cut in half. That means BC and DC are congruent. Right? So that's the definition of a segment bisector. That gives me my three things marked. So these triangles are marked by hypotenuse leg. Watch when you're using a hypotenuse, when you're using 90-degree angles, just because it's 90 degrees doesn't mean it has to be a hypotenuse leg. It could still be something like side angle side, or some of the ones that we'll look at as we move forward. We now have three ways to prove triangles congruent, which is side angle side, side side side, and hypotenuse leg. While the last two in the next section. Also, just on what we'll do, this is fill in the blank, so I left it how it is. But if we say these are perpendicular, I would say my angles are right angles. I wouldn't make you state out that the triangles are congruent or are right triangles. All right. So I said the angles are right. I can mark that down, and then that gives me the 90 degrees that I need. Some of that depends on what book you're using on how they do that, right? And that is the end of section 5.5 and or side, side, side and hypotenuse leg theorems.